Imagine a star so small it could fit inside planet Saturn. Seems impossible, right? But guess what? We've just found one. It's important to define what we mean by star. This isn't a neutron star or a white dwarf, but a main sequence star burning bright with fusion. This tiny titan is known as a hot subdwarf, and it's not just breaking records, it's rewriting our understanding of star sizes. For ages, we thought red dwarfs were the smallest stars. You know, stars like Proxima Centauri and TRAPPIST-1. They're everywhere, and they're often the focus of studies because they seem to have terrestrial planets in their orbit. But they're not the smallest after all. Let's take a closer look at this recent discovery. Here's the Sun, Saturn, and Earth. But let's focus on the last two. This is TRAPPIST-1, one of the smallest red dwarfs we know. It's just a bit larger than Jupiter in size, but much more massive. It's about 93 times the mass of Jupiter. But then there's this newly discovered star, TMTS J0526b. The size difference is dramatic. It's smaller than Saturn and about 7 times the size of Earth. This star, located about 2,700 light-years away from us, contains about one-third of our Sun's mass. It's not even that hot. It's about 2,200 degrees Celsius, even cooler than a typical red dwarf. If we found this object by itself somewhere out there, it would be one of the biggest mysteries in astronomy. One of the main reasons this object was discovered was because it's in a binary system. In the binary system, two stars orbit around a common center of mass. This star also breaks another record. This system has an orbit of just 20 minutes. That's right. Every hour, these objects go around each other 3 times. This is also a record. It's technically the star with the shortest binary orbit. This star is still conducting fusion and is still in its main sequence stage. The researchers here also suggest that this is possibly an absolute orbital minimum. Basically, this is as low as it gets. They don't actually think it might get any lower because at that point, either the star will change as well, becoming a white dwarf, or the white dwarf might start completely destroying the star because of its much higher density and the tidal effects, thus eventually causing a nova and turning the star into something else, maybe even a planet. So there you have it. It's officially the smallest star in the galaxy, at least as of 2024. And who knows what other cosmic surprises are waiting for us out there in the vast expanse of the universe. Stay tuned!